So let's now solve this together. And for this, I'll start by adding a new file here, exercise.go in the exercise2 folder. And I'll add the package entry. Package here actually will be main. And I'll add the func entry here and the function, the main function, like this. That's task number 1. Task number 2 is that we should add 2 variables to the file, the number pi and the circle radius. And for this, I'll add a new variable named pi and use this shortcut for storing 3.14 in it. Now, Go then automatically infers that this is of type float64, since you do create floats by adding a dot after the integer part and then adding the decimal places. Alternatively, you could of course also have done something like this here if you wanted to, or maybe even switch to float 32, which would be sufficient here for only 2 decimal places. Now I'll go for this shortest possible approach though. And then we should also store the radius, that's the other variable we should create, and should store a value of 5 in it. And therefore here I'll do that like this, and here Go infers a type of int, which is fine, because this is a number without decimal places, so using an integer makes sense. We could force it to be a float by adding .0, then it would still be 5, but it would be a floating point number, since it has a decimal place, as you can see here, but there really is no reason to do this here, so I'll go back to just 5 like that. In task number 3, we should now use these variables to calculate the circle circumference and store it in a new variable. And therefore, I'll add this new circumference variable, again using the shortcut, and that is 2 times pi times radius. And here we now have a problem which we in the end faced before in this section as well. We have mixed types. Here, in the end, we combine float64 with int, and that does not work like that. So in order to make it work, we have to convert one of the 2 numbers. And here it's up to you how we want to make that conversion. We could convert pi, which is a floating point number, to an integer by using the int command. We haven't used that before, but just as there is a string command and a float64 command, there is an int command for converting floats to integers. Now we could do that, and that would work. We could now output circumference, but this would in the end then lead to 2 times 3 times 5, since the int command basically just cuts off the decimal places and just gives us the integer part of that number. And that's not the mathematical correct circumference, which I want you to derive though. You should make sure that the value is correct. And therefore, instead of converting the float to an int, we should do the opposite and actually convert the int to a float by using the float64 command. And yes, of course, we could have just created a float up here as I showed you a couple of seconds ago, and then we would not have to do the conversion down there, but maybe we're using the radius in other parts of the program as well, where we want an int. And even if we don't do that, it's a nice practice to do that conversion and use an int here, but then convert it to a float here when we need it. And then we can also output this with the format package, which we have to import. And here we then can call print ln with a capital P and output the circumference. And if we now save all of this and I dive into that exercise2 folder and then run my exercise go file, I indeed get my circumference here. And here we have that little precision error at the end. This simply is an error which you sometimes get when doing floating point arithmetic in Go, or actually in a lot of programming languages, because we have that limited precision. And therefore, even with float64, which still has some limits, you can sometimes get tiny errors like that in the later decimal points, in the later decimal values in the end. But we can ignore this here and instead move on to task number 4. And here we should output a formatted string. And we learned about these useful functions like println for outputting strings, and we learned about that alternative command that allowed us to control the formatting in greater detail, printf. Printf took that string as a first value, where we basically have our text. So this text here, which I have in the instructions, where we then want to replace x and y with concrete values. And for x, where I want to just output the radius, I just will use %v as I showed you before. But for the circumference, where we get a floating point number, I don't just want to use v, which would be that very long number, but instead I want to limit it to just 2 decimal places so that we output 31.40. And we can do that as explained at the bottom of the instructions file by using this special placeholder in the formatted string. This tells Go that we're outputting the value of a floating point number and that we want to limit it to only 2 decimal places that should be output. And the other decimal places will be cut off. Now we just have to add a comma-separated list of all the variables that are referred here in this string. And the order matters. And the first variable therefore should be the radius, since that's the first variable we reference in here. The second reference, on the other hand, is about the circumference, so that's the second variable I add here. And with that, if we save this and we re-execute this Go file, we get that sentence down there, and you see the concrete values in the way we want them. And that's it for this exercise. We again practiced what we learned, and therefore hopefully it's clear how you can work with floats, how you can do math with floats and integers also combined, and how you can then output results, and how you can also control how strings are formatted with functions like printf. I want to dive back into packages and modules. Especially the package term is a term you heard quite a lot throughout this section here, and therefore it's now time to fully clarify what exactly a package is and what a module is and how these concepts are related. Now, for example, FMT, format, is a package in Go, and this is one of the built-in packages, but there also are packages provided by other developers. On the Golang page, golang.org, you also have the packages part where you can dive into all the built-in packages, which are part of that so-called standard library. And you can also dive into popular community packages by going to that separate page. And that would then be packages which are not built into Go, but which you need to install separately. Also something we'll see throughout the course, but not something we'll focus on right now. Instead here, I want to clarify what a package is in general and why we have it. And for that, let's also not forget that our own Go file also has this package instruction here at the very top. Because every Go file you create needs to belong to a package. And you can have multiple files that belong to the same package or multiple files that belong to different packages. And it's very common that for bigger projects, you might split up your project into multiple packages that deal with different aspects of your project. Or maybe you put it all into the same package if that makes more sense to you. It is something which will also come over experience. Now, whenever you want to use some functionality in one of your code files that is defined in another package, you have to import that package as we're doing it here with the built-in format package. But then we also have modules. And in the end, we also have modules to organize our code. Now, modules are bigger than packages. If you create a new Go project, you typically make that project a module. A module has a unique identifier, and you can distribute it as a third-party library to share it with others potentially if you want to. And as I just said, every Go project goes into a new module typically. Now, you can use multiple modules in your module by importing them, and you do create and manage modules with the go mod commands and the go.mod file, which we'll see in action in a second. Now, we also have packages, and I mentioned that we would import from packages, whilst now here I'm saying that we import from modules. Well, packages are simply grouped together into a module. So every module contains at least one package, but potentially also multiple packages. For example, here's the codebase of an Azure Go module. Azure is a cloud service by Microsoft, and they have various modules that help you work with that cloud service from inside your Go code. And here's an example module to which you find a link provided by the Azure team. And you can tell that it's a module because if you look through all those files here, you'll ultimately find that go.mod file. But this module then is actually made up of multiple packages. You can tell by the fact that if you click into the code files, you for example find that this file belongs to the package service bus, whereas when we then dive into the Atom subfolder, for example, that belongs to the package Atom. So here in this module, we have at least two packages that make up this module. And therefore, when you build a module, you can have multiple packages in there to organize and group your code into logical units. And it's up to you as a developer to decide which kind of code should go into the same package because it's related, and which kind of packages should go into the same module because the packages then overall might still be related. You do put multiple files into the same package by using the package instruction in your code file. So this instruction here. And if you do have multiple packages in a module, you should store them in subfolders. So the files that make up a new package should all go into a subfolder, which then typically also has that package name as a folder name. And then, as mentioned before, it's ultimately the packages that are imported, but since modules are made up of packages, we can of course also say that we import from a module. But ultimately it's always a package from which we import. Now that could be super confusing at this point, and therefore in the next lecture we'll see an example of how we could create a module here and how we could then add multiple packages in that module and how we can then import from our different packages.